So tonight is log equations. So anytime you have an exponential equation where you have the variable in your exponent, you're going to wind up having to turn this into a log. But before you do that, you have to isolate that term with the exponent, meaning here I have to divide away this 100. So what I wind up with is 1.35 to the n equals 98.5. And then once that term is isolated, you're going to turn it into a log. So this would become the log with base 1.35 of 98.5 equals n. And that is my exact answer. So when you're doing these, you're not going to want to put anything in your calculator until the end. So here, in exact answer, this is what you would put in. Okay? And then we would put that in our calculator. Depending on what calculator we would have, we would go math, log base 1.35 of 98.5. Or if you have a TI-83, you would do the log of 98.5 divided by the log of 1.35. So notice how either way, you get the same answer. And that's going to be my rounded answer. Okay. So same deal for this next one. We have to isolate the e before we can turn this into a log. So I'm going to subtract this 10 from both sides. And I'll get negative 40 e to the 9x plus 3 equals negative 156. And then I'll divide both sides by the negative 40. .9. And now I'm going to do the log. I'm going to turn this into a logarithm. So it would be log with base e of 3.9 equals 9x plus 3. But we know log with base e is also called the natural log. So this becomes the ln of 3.9 equals 9x plus 3. And now we'll subtract this 3. And then we'll divide this 9. So your exact answer is the ln of 3.9 minus 3, and then that whole thing divided by 9. And then that would make your rounded answer the ln of 3.9 3 9 negative 0.18211. It's 5 decimal places. There you go. There's 4 decimal places. Okay. I put this next one on here because there's one rule that I think a lot of people don't think of that would make this question way easier. And that is, if we remember correctly, there's a rule of exponents that says if you have x times y to the a, that's the same as x to the a, y to the a. And now this rule works in both directions. So you can start here and end here, meaning you see how these both have a w? Just like these both have the a, I can take it out. So I can rewrite this as 3 times 2 to the 4, and then all of that to the w. And 3 times 2 to the 4, it's just a number. So 2 to the 4 is 16 times 3 is 48. So what I have here is 48 to the w equals 12, which is then log with base 48 of 12 equals w. It's my exact answer. And so then my rounded answer .6419. So when you're working with logarithms, the principle is similar in that if you're taking the log and your variables in here, then you need to turn it into an exponential. So this would become 2 to the 4 equals 4t plus 6. And 2 to the 4 is 16. And so then subtract the 6 and divide by the 4. Then I'm going to say that my exact answer is 5 halves. Make sure you reduce. And your rounded answer is 2.5. Now, one of the things we need to remember about logarithms is that their domain is only the positive numbers. So we need to make sure that if we plug this answer back in, we would be doing the log of something positive. So 4 times 2.5 is 10, plus 6 is 16. We can do the log of 16, so that one's okay. As an example, if my equation somewhere had the log of x minus 3, and I got 2 as a solution, I can't plug 2 in here because 2 minus 3 is negative 1, and I can't do the log of negative 1. So if my equation was log of x plus 3 and I got negative 2 as an answer, I could plug negative 2 into this because negative 2 plus 3 is a positive 1. So it's not about what your solution is, it's about would you be taking the log of a negative, okay? So you always have to check that on these. So for this next one, I need to isolate the log. So we'll do that by adding this 10. And then dividing this negative 2. And now we're going to turn this into an exponential. So this would become 6 to the 5 equals 5y plus 4. 6 to the 5 is 7776. So 7776 equals 5y plus 4. If I subtract the 4, I'll have 7772. And divide the 5. That is my exact answer. And nope, I divided by 4 instead of 5. There you go. And my rounded answer, 1554.4. And so if you have more than one log, then you need to combine them before you can turn it into an exponential. Ooh, I didn't check this one. So let's plug it back in. I don't know what it will be, but this is positive times a positive will stay positive, plus will stay positive. So I'm definitely going to wind up taking the log of a positive number. Okay. So we have to combine these two logs before we can solve. And so since this is addition in between, I'm going to multiply t times t plus 3 and get log base 2 of t squared plus 3t. Then I'm going to turn this into an exponential. 2 to the 6 equals t squared plus 3t. 2 to the 6 is 64. So t squared plus 3t minus 64 equals 0. And then I'm gonna have to use the quadratic formula on this one. So negative b plus or minus the square root of b squared minus 4ac over 2a. $265. So they're not asking me for exact answers here anywhere. So they just want rounded. So let's put this in the calculator and get some decimals. So we have negative 3 plus the square root, oops, the square root of 265, nope, yep, 265 divided by 2, negative 3 minus the square root of 265. Oop, I forgot my parentheses on that one. Negative 3 minus the square root 265. There you go. Divided by 3. What am I doing? Jeez. All right. Let's try that one more time. Here we go. 6.6394 negative 9.6394. Okay. And then we have to check it. So if I plug in 6 and something more here, I'll get that same 6 and something more, which is positive. Here it would turn into 9 and something more, so that's still positive. So this answer is okay. But if I plug in negative 9 point something right here, well, I can't do the log base 2 of a negative anything, so that answer is no good. So my only answer is 6.6394. Okay. And again, you should be checking every single one of these every single time. All right. So these are pretty weird. I want you to notice that the squared is on the outside here. And so over here, I'm going to use my leapfrog. I'm going to take this 10 and bring it out to the front. I can't do that here because the 2 is on the outside. See the difference? So I can't bring this one out, but I can bring this one out. And then I'm going to move everything to one side. Minus equals 0. So now, had this just been a z, I would have been looking at 5z squared minus 10z equals 0. And if I was solving this, I would take the GCF, so that would be 5z. And then I would set each one of these equal to 0. And then solve them, right? So I'm going to do the same thing over here, only instead of just z, it's with the log base 3 of z. So 5 log base 3 of z would leave me with a log base 3 of z minus 2 on the inside. And then I'm going to set each one of these equal to 0. So divide both sides by 5. That's still going to be 0. And then we turn this into an exponential. So 3 to the 0 is z. And anything to the 0 power is 1. Take a second and check 1. I can plug a 1 in there. And 1 to the 10th is still 1. So that's positive. So I can plug it in there. So 1 is good. On the other side, I would move the 2 over. Add the 2. And then turn this into an exponential. 3 to the 2 equals z. See, I was getting ahead of myself with the answer. And 3 to the 2 is 9. So let's check 9. Log base 3 of 9, that's fine. And 9 to the 10th, that I don't know what it is. It'd be a huge number, but it would be positive. So these both work. Okay. So this next one is going to function very similar to that last one. I'm going to take this -2 and bring it down. And then I'm going to get this all together on one side so that it's log base 4 of y squared plus 2 log base 4 of y minus 15 equals 0. So you can do these one of two ways. You can do them the same way that I did above, where you keep the logs, or you can substitute. So I can come over here and say, okay, well, what if I change it so that instead of log base 4 of y, I'm going to say x. You can pick any letter. X is the log base 4 of y. No. X squared plus 2x minus 15 equals 0. Well, that factors. X plus 5, x minus 3. And then I have x plus 5 equals 0, and x minus 3 equals 0, so that's -5 and 3. But you then have to turn this back. So then I would have to say, okay, well, since x is the log base 4 of y, then the log base 4 of y equals -5, and the log base 4 of y equals 3. So this would be 4 to the -5 equals y. This e to the -4 means to move this decimal point over 4 times. So it would be 0.00097, which the 7 would round the 9 up. So it would be 0.0010. And then on this side, it would be 4 to the 3rd equals y, so that's 64. Let's check them just to be safe. So this is positive, so I can put it in there. And then the -2 means to take the reciprocal and then square it, but you're not going to make it negative at any point, so this is okay. And if you're not sure, you can always just do this to the -2 and double check. Oops. -2. Yeah, I knew it was going to do that. So answer to the -2. Yeah, I put it in wrong. See? Okay. And then 64 is fine here. And then 64 to the -2 is also not going to be negative. It's going to be 1 over 64 squared. Still positive though. So both of these answers work as well.